Yes, Radhika ma'am. Sorry, Naina ma'am.
Yes, sir.
Yes, ma'am. You can start now.
Okay, sir.
Yeah.
A hearty welcome to one and all present here. Alamudi Ratnamala Institute of Engineering and Technology, run by Kochi Vidya Charitable Trust. The Department of Computer and IT welcomes our today's guest speaker, Mr. Cyrus Lentin, and all the participants for 1 week online faculty development program on emerging trends in AIML. So I would like to welcome Mr. Cyrus Lentin, sir, from Next Data Solutions, Mumbai. He has more than 30 years of industry experience with extensive domain expertise in data management, data analytics, business intelligence, and data visualization. He has completed the training for Certified Ethical Hacker, Blackboard Product Management, and Mobile Application Development. He has hands-on experience as a data scientist, proficient in Python and R programming, and even worked as a big data analyst. So, as you have such a huge years of experience, so I request you to say few words and share your experience with us.
Can I take over, Naina ma'am?
Yes, sir.
Okay. Good evening, everybody. And thank you, Naina ma'am, for your kind words.
Welcome, sir.
Today, we are going to talk a little bit about linear regression. But to start off with, I will lay some foundation. Sharing my screen. Everybody can see my screen, I guess.
Yes, sir.
Yes, sir.
So initially, we started with spreadsheets. Everybody wanted to work with spreadsheets. And then we moved on to transactional reporting. That gave way to early business intelligence, which was followed by online transaction processing and advanced operation analysis. Today, we are in the region of predictive analytics. And one of the things which predictive analytics includes is machine learning. Today, if you want a job as a data engineer or data scientist, you must know predictive analytics. That means you must know machine learning. As a machine learning engineer or a data scientist, you require 3 skills: mathematics and statistics, good computer science background, and sound business domain knowledge. Today, we require computer science simply because there's a lot of number crunching happening. How do you crunch the data? We bank on some mathematics and statistics model. Obviously, business domain knowledge is important because without that, you will not know what is good or bad for the business. So a person with all the 3 will make up a good data scientist or a good data engineer. However, having said that all 3 is required, today we've reached a stage where if you want to do machine learning applications, then we don't need to understand the statistics behind the algorithm. It's like a black box to us. You don't need to know the internal working of the algorithm. It is important to understand what the algorithm does. So when is that algorithm useful? It is important to understand what is the input required by the algorithm. it is important to understand the output and they interpret the output provided by the algorithm. And I'm going to spend a lot of time on this to prove what I'm saying, that the tools are available that we don't need to know the statistics behind the algorithm at all. So there are many people many students especially who are afraid of doing machine learning simply because they say there will be a lot of statistics and mathematics. I say no, don't worry about that. It is good to know. It is good to know, but unless you are doing programming for the algorithm itself, unless you're doing the programming for the algorithm itself, you don't need to know the internal workings of an algorithm. So to create machine learning applications where you're just going to use the algorithm, do you need to know the internal working? No. You need to know the usage. You need to know what is the input, and you need to know how to interpret the output. Have I laid the base very clearly, guys? Guys, please respond. I would like to have some verbal indication that you all are following me.
Yes, sir.
Yes,
All
sir.
the other people, I can see many students out here, and I know students are apprehensive of statistics and mathematics. Okay, so proceeding further, sharing my screen again. Machine learning, what is machine learning? It is the application of computer algorithms to provide the system the ability to learn without being explicitly programmed. Very important. It learns without being explicitly programmed. I'm not going to go into the technical details, but what it means that we have to provide the computer with some experience. And in our case, the experience is provided by the past data. How does human being learn? Human beings learn through experience. We have to provide a similar experience to the machines. And for machines, the experience is past data. Machine learning
Yes, sir.
process begins with observations of data, and the machine or the algorithm looks for patterns and makes decision based on examples so that we can provide decisions in future. The primary aim is to allow the computers learn automatically without intervention of human intervention and adjust actions accordingly. This is very important. The system adjusts the action according to the data. This is the second thing that we will be doing. We'll spend time on this. I will not change the program, but the output will be diametrically different. So let's start about linear regression. You go to the market, you visit the general store and ask for 1 kilogram of sugar. The shopkeeper asks you to pay 50 rupees for 1 kilogram. And to your horror, you realize you have only 25 rupees. So what will you do? You will tell the shopkeeper, give me only 500 grams of sugar. Can anybody tell me why?
Because we don't have enough money to buy the sugar.
Why did you ask for 500, not 250, not 750? Why did you ask for 500 grams of sugar?
Because
And
we
not
were
250 grams?
expected to buy.
Go ahead, Akash, you're on the right track.
Yes, sir. Actually, we were expecting to buy 1 kg, but we could not afford. So that's the reason we are, buying half kg. Maybe.
Half kg will come in 25 rupees.
As the price is about 50 rupees per kg, so 25 rupees per half kg.
Okay. So, Akash, do you realize what you have done? You have used the principle of linear regression. You have created a linear equation and worked on linear regression. Did you realize that?
No, sir.
Okay, so as we go further, you will realize what I'm saying.
Sure, sir.
That is how easy it is to use linear regression. Linear regression can be used in day-to-day life in many, many applications. Let us take a look how we can use linear regression. Linear regression नाम बहुत बड़ा है, but in reality it is very, very simple. So linear regression is used to predict the value of a dependent variable based on value of at least one independent variable. In our case, what was the dependent variable? How many grams of sugar we ordered?
500.
So what is the dependent variable? The quantity. What is the independent variable? Price.
Correct.
So the value of the dependent variable is based on the independent variable. What do you mean by the dependent variable? Dependent variable means the variable which we wish to predict or explain. Independent variable, the variable which is used to predict or explain the dependent variable. So typically, linear regression is used to understand the phenomena and make predictions based on that. It is one of the most commonly used tools for business analysis. It is easy to use and applies to many situations. Two things are very, very important. Independent variables must always, independent variable must always be continuous numeric or categoric numeric. What is continuous numeric? What is continuous numeric? Can it be integers? Continuous numeric means there are numbers which don't have a fixed category, fixed interval. For example, age. I can have age as years, or I can have age as years and months. Or I can talk about units in terms of weight. Kilograms can be 100 kilograms, or it can be 101 kilogram, or it can be 101.1 kilogram. So there is absolutely continuous number. Categoric numeric variables are variables which have only a few numbers. For example, 1, 2, 3, 4, 5. That is categoric variable. There will be no other category except 1, 2, 3, 4, 5. So independent variables have to be continuous numeric or categoric numeric. and dependent variable must be only continuous numeric variable. Examples: house price and area of the house. We all know the price of the house is dependent on the area of the house, right? We also know that the sales of a product is dependent on the rate per unit. If the rate per unit is less economic, then the sales will be more. These are some of the applications in which linear regression is used. Estimate the salary. Estimate the churn. Churn means turnover of the employees. Estimate resource demand. House price prediction. House demand forecast. Sales volume and return on investment. One thing that is common in across all this is these values which we are forecasting or predicting. They are all continuous numeric values. And if you go back, the dependent variable should be continuous numeric. So this falls in line with what we learned earlier. In linear regression, we can predict only continuous numeric values. Some more applications. Here also you will see everything is continuous numeric value that we are trying to predict. Customer value, customer spend, balance flow into transactions, new account volume, claim amount estimation, revenue regression model. So at a broad level, linear regression we classify into two: simple linear regression and multilinear regression. We will do both of them. Single linear regression has only one dependent variable and has only one independent variable. By the way, dependent variable can always be only one. You cannot have multiple dependent variable. Dependent variable is always one. But independent variable in simple linear regression is only one. There must exist a correlation between X and Y. We will understand what is correlation. Changes in Y are assumed to be directly related to changes in X. And linear relationship between X and Y is described by a linear function. In the example of sugar, 1000 grams is equal to 50 rupees. That is the linear function. 500 grams is equal to how much? Remember how we used to do this equation in school? That's exactly how we do linear regression. Again, very important, independent variables must be continuous numeric or categoric numeric. Dependent variables are only continuous numeric. There are certain assumptions that we make for linear regression, and the first assumption is correlation. There should exist a correlation between the dependent and independent variable. When there are many independent variables, there should not be correlation between the two variables. There exists a linear relationship between dependent and independent variable. I explained you what that relationship is. And the errors are normally distributed. We'll talk about this later when we are doing the errors. Can everybody see the screen? Can everybody see
Yes,
the
sir.
screen?
Yes, sir.
Okay, what is shown on the screen is spend, marketing spend on one side and sales on the other side. What is seen out here when we are making a plot, that as the spend increases, the sales has also increased. And the correlation coefficient is 0.9988. Let us understand what is this correlation coefficient. Correlation coefficient is a value between -1 and +1. It tells you how strongly two variables are related to each other. We use the correl function in Excel and cor function in Python to find the correlation coefficient between two variables. A correlation coefficient of +1 indicates a perfect positive correlation. That means as X increases, Y is also increasing. As X decreases, Y is decreasing. A correlation coefficient of -1 indicates a perfect negative correlation. That is, X increases, the variable Z is decreasing. As X decreases, variable Z will increase. It's a negative correlation. Correlation coefficient near 0 indicates no correlation. As X increases, variable W may increase or decrease. As variable X decreases, variable W may increase or decrease. There is no fixed pattern, and therefore there is no correlation. A general way to interpret the calculated correlation is as follows. 0 to 0.2 plus or minus is considered as weak correlation or very weak correlation or negligible correlation. 0.2 to 0.4 plus or minus is considered as weak correlation. 0.4 to 0.6 plus or minus is considered moderate correlation. 6 to 8 and 8 to 1, strong and very strong correlation. Linear regression is effective only when there is strong correlation or very strong correlation. Otherwise, linear regression does not give good predictions. What type of correlation are we having out here? Anybody would like to say? What type of correlation is that?
Very strong.
Very strong correlation, yes. So we've established that there is a correlation. We established that there's a very strong correlation. The second thing that we do is to establish the data distribution pattern. Generally, we do that using a box and whisker plot. If there are any outliers, outliers are points which are outside this. either above the upper limit or below the lower limit. If there are outliers, we need to handle it. Outlier handling is a detailed subject which we will not go into. In this case, it's a simple data set. There are no outliers, so we can easily proceed. What else do you see from this? We see that a majority of the data is concentrated in the middle. More data is towards the upper side than lower side. Again, which fits into the pattern. Out here, you can see some dots out here. Which is reinforcing that as the data is going up in terms of X, Y is also going up. Can we see that out here on the box plot? More data in X. Similarly, there's more data in Y. Then we can ask Excel to draw a regression line. This is the regression line. And we can also ask Excel to prepare the linear regression formula. This is the linear regression formula. Along with that, we ask Excel for R square. R square tells us how the regression is going to be, how good or bad the regression is going to be. So let's talk briefly about R square. It's a measure of how close the data is to the fitted regression line. Zero R square explains none of the variability of the response data around its mean. If R square is less than 0.65, data set is not to be used for regression. This is very, very important. That is the rule. What is the R square here? What is the R square, guys?
99%.
Can we use this data for regression? What should be the cutoff?
Yes.
What should be the cutoff?
It should be 65.
6.
So this is much, much more than 65. We can easily use this data for prediction.
I request the participants, please make this session interactive as sir is asking questions.
We now understand what the equation is. The linear regression calculates an equation that minimizes the distance between the fitted line and all the data points. A model fits well if the differences between the observed value and model's predicted value are small and unbiased. Residual or error is a difference between observed value and fitted value. Technically, OLS regression minimizes the sum of squared residuals. It is the equation which is used to predict further values. And we'll see how the equation predicts further values. What is the equation out here? Y is equal to 10.622x plus 1383.5. So this is what we do to predict the interval, predict the new values. we will use 10.622 into F3. What is F3? Whatever is the X plus 1383. And that would be the formula which will be used to predict new values. It is so simple. Let me actually take an example and show you in Excel how simple and how fast we can do it. This is the same set of data you saw in the PPT. I'm going to first create a scatter plot. Based on scatter plot, I will create a trend line. Add a trend line. Along with the trend line, I will ask also give me equation and R square. Did we get the same formula? How will I predict? Let's say if I have to predict this. Is equal to 10.622 into plus 1383.5. So simple. What are we predicting? We are predicting the sales when the spend is going to be 8,000 or 9,000. Notice the spend out here is already 9,000 is given. And what is that? 94.871. And here what are we predicting? 96.96981. Very, very close to it. This is very good prediction. Now this much is easy. What if I had to do the entire calculation manually? I had to calculate the R square manually. I had to calculate the equation manually. Let us do it. Let us see how we can do it. And we will see what are the problems associated with that. Sharing my screen. So this is the formula for R square. We have to first calculate the R. R incidentally is the correlation coefficient. I can calculate using it by Excel formula also, or I can calculate it manually. Manually means I will use the Excel, but I will use it only for totaling, multiplication and sum. I will not use a standard Excel built-in formula. So first let's understand correlation coefficient. Now you can see what I'm doing, right? This is R and this is R square. Now we will do it manually. First, sum of xy. So let us create a xy first. Sum of x square. We want x square and we also want y square. Sorry. Sum of x square. We also want y square. X raised to 2 y raised to 2 Then I've given this formula out here. It's a huge formula. Can you see it, guys?
Yes, sir.
Can you see the formula?
Yes, sir, we can see it.
It's slightly complicated formula, so I've just written it down. But what this formula does is it does exactly what is given out here. N is number of elements into sum of xy minus sum of x into sum of y, the whole square root, n into sum of x square minus sum of x raised to square, n into sum of y square minus y raised to square. Slightly complex. But do you realize that we got the same values as the Excel formula?
Yes, sir.
Do you realize that? After doing all that, we've got the same. Now, if I can do that in a jiffy, why should I do all the calculation? I'm going to ask another question later. Let's continue with this for the time being. Since we've done the R square, now we'll do the equation. We'll get this equation. What was the equation? What was the equation? Y is equal to 10.622x plus 1383.5. we should be able to get the same equation. Now to get that equation, what is the formula? Let's take a look at the equation formula. There are two parts to the equation, the slope and the intercept. Slope is the one which is along with the x. The intercept is plus after the plus sign. Now we need to do average of x minus y, average of y minus y, and sum of average of x minus x raised to square. So let us try to do all that, and then we'll see how the final formula takes place. This is the spend, this is the average. So I'm going to use the formula of average minus x. Average minus x. I'm making it absolute value so that it will not change. When I copy it down, the cell reference remains that only. This is average of y. This is average of x minus x raised to square. So let's do the square first. Raised to 2. Average of y minus y. This is average of x minus x into average of y minus y. So let's do that. Equal to average of x minus x into y minus y. Having done this, I can get the slope. What is the slope? I can get it in two ways. I can use the Excel formula also. I can use the slope Excel formula. And I can also use the same thing for intercept. Intercept Excel formula I can use. Do you realize it's given the same values? 10.62 and 1383.47. This is what was there in the formula, isn't it? That's how we are going to create the formula again. sum of fx divided by this. Sorry, sum of xy, this divided by this will give me the value. Intercept, very easy. And you see we are getting the same values whether we do it manually through Excel formula or through the graph out here. Now let me ask you a question, guys. When you can use an Excel formula to get the values, or you can use the Excel graph to get the equation, do you have to do all the effort of creating the formula manually, R square and then the equation? Guys, please answer. Think about it and answer. Okay, let me ask you another question. Suppose you are working and you have to find out the R square and the formula. Is your boss bothered how you do it? Whether you do it through the equation or whether you do it through manual calculation?
No, sir.
He is not bothered. In fact, he will say the faster you do it, the better.
Yes,
Isn't
sir.
it?
Yes.
So now I'm asking the question, sharing the screen again. Do you really need to know the entire equation of how to do the linear regression? Coming back to my first slide. Do you really need to know the internal working of an algorithm?
No, sir.
Yes or no?
No.
Everybody agrees with him. I have proved it beyond doubt that we don't really need to look into the internal working of the algorithm. Yes, supposing I had to program this algorithm, then I needed to know. But if I just want to use the algorithm, I need to know when to use it. I need to know the input which I have to give, and I need to know the output. I need to know, interpret the output. Let's say I get R square. .25. Should we go ahead with the linear regression?
No, sir.
So therefore, we need to understand these things and we should know how to interpret the output which is given. Is that clear? Excel has given us the R square and equation both as the output. It is not telling us what to do. It is just providing the output. We need to understand and we need to interpret the output. Is that clear?
Yes, sir.
Everybody?
Yes, sir.
Carrying on further. How do we know if the predictions that we have made are good or bad? We bank on something called as root mean square error. Root mean square error this is the error, but that you can see in the red line. It is the gap between the actual dot and the regression line. The distance between the actual and the predicted are represent the error. So we can draw a straight line from each blue dot to the blue line, taking a mean of all these distances. After squaring them and then taking the root will give us the RMSE. RMSE is an important indicator of how spread out the residuals are or how much the errors are. In other words, it tells you how concentrated the data is around the best fit. Lesser the RMSE, the better. Smaller the RMSE, the better. Lower RMSE of less than 100 indicates a good fit. But RMSE at many times is data dependent. If there is a lot of data, there will be a high RMSE. Since there is no fixed benchmark, we can only say lower RMSE better. It depends on the distribution of data. Therefore, in case we have a higher RMSE, it means that we need to probably change the evaluation to another matrix called as scatter index. Scatter index internally uses RMSE only. Scatter index internally uses RMSE. It is RMSE divided by mean of the actual values. How do you interpret scatter index? If scatter index is less than 1, predictables are acceptable. And scatter index closer to 0 is better. So if we have two models, and for model 1, scatter index of model 1 is equal to 0.3 and scatter index of model 2 is equal to 0.2. Which model is better? Guy is waiting for an answer. Which model is better?
Module 2.
Yes. Model 2 is better. Why is it better? The lower scatter index is better. Is that clear?
Yes, sir.
For those who are interested in the slides, I will be sharing the presentation with Naina ma'am. and you can collect it from her. You can go through it. My contact is
And,
available at the last page, and you can connect.
Excel sheets also, sir.
Beg your pardon?
Yes, Excel sheets also, sir. Please share.
Excel sheet also, okay. I'll give you the
Yeah.
Excel sheet with the solution.
Yes, sir. Thank you, sir.
So we spent some time on this, and the first part we have clearly identified. We have conclusively proved that we don't need to understand the internal workings of an algorithm to use the algorithm. So though we say that a data scientist, good data scientist, needs to understand mathematics and statistics, a decent elementary knowledge of statistics is good enough. If you want to do an application of machine learning, if you want to do programming with machine learning, if you want to do programming for machine learning, then you better understand all the details working of this, like I showed you how to do linear regression. And this is just with simple linear regression. Formula for multilinear regression, where there are more than one independent variables, are even more complex. We'll take a look at that also. Now I'm going to the other part. Here I want to show you how machine learning learns from the data. And without changing any program, obviously you realize I can't change the Excel program, but just based on the data, we will get diametrically opposite results. In one case, as X is increasing, Y will also increase. In the second case, it is the other way around. As X increases, Y will decrease. So without changing the program, we will see that the output is completely different. Can I proceed, guys? Are we clear what we are going to do now?
Yes, sir.
Okay, there's something which is pending. I've not shown you the calculation of RMSE.
Yes, sir.
RMSE calculation is even more complex. I have to use the predicted. So what is the predicted? And here I'm going to find the difference between the two. Y minus the predicted whole raised to 2. And RMSE is basically square root of that. So let us do the sum of these two first. There is no Excel formula. So I am computing this in a roundabout way using or I can use this square root of this value will also give me the same result. One calculated manually. And this is the scatter index. Scatter index in this case is 0.03. Is it good? Is it good?
Yes, sir.
Scatter index is very good.
Yes, sir.
Obviously, when the lines are going to be so close to each other, there is no error, and therefore the scatter index is bound to be good.
Yes, sir.
I'll send this Excel file also, but let's go to the other Excel file. This is my data available to me. What I need to do is to make a linear regression for equation for hits and revenue. It's a e-commerce site. The more hits we are getting, the more revenue we are getting. So let's first of all make the scatter plot. Create the trend line. Linear trend line is given. Display the equation. Y is equal to 1.3997x. 1.3997 into x plus 214.74. Can you see as the hits is increasing, the revenue is also increasing? Is that clear?
Yes, sir.
Yes, sir.
Now let's take
Yes, sir.
another sheet. Another set of data. And in this set of data, again, we'll create the scatter plot. And what do we see out here in our scatter plot? Our original data itself is showing that as X is increasing, Y is decreasing. As X is increasing, Y is coming down.
Yes, sir.
Can you see that?
Yes, sir.
Now let's see if the machine learning is smart enough to understand this and create a formula accordingly. Create a trend line. How do we create a trend line? Click on the right click on the dot. Add trend line. Display the equation, display the R square. What is the formula? Minus 1.3791 into X. Minus 1.3791 into X plus 1111.2. And you see, as the hits is increasing, revenue is actually decreasing. Did we change the code?
No, sir.
Did we change the code?
No, sir.
Obviously, we can't change Excel code. So there's no way I could have changed the code. But just based on the data, the machine learning interpreted the data correctly and created an equation which gave me exactly the opposite result from the first linear regression. Is that clear?
Yes, sir.
Which is what I am saying. The computers learn automatically without human intervention or assistance and adjust actions accordingly. Without being explicitly programmed. Now, do you understand the significance of these terms?
Yes, sir.
Okay. We've done this calculation of R square manually. We've done this also calculation of linear equation manually. We found out the root mean square error. Here was the first example where there is positive correlation. And you can see that as the hits is increasing, the revenue is also increasing. The data is also like that. In the next slide, we'll see that there is a negative correlation. the data is opposite. As the x is increasing, the y is decreasing. And you can see that the output also has come in the same way. As x is increasing, y is actually decreasing.
Sir, screen is not visible.
Oh, I'm so sorry. In the first instance, we saw already this. The data is, as x is increasing, the y is increasing, and the output is also the same way.
Yes, sir.
In the second instance, we didn't change the program, but the data changed. And because the data was different, it was showing negative correlation. The output will also show negative correlation. As x increased, y was decreasing. So we learn machine learning is completely based on the data which is provided. I don't have to explicitly program my computer to change the logic. The machine sees the data and learns without being explicitly programmed. How does it learn? Like human beings, computers also learn from experience. And for computers, the experience is what? Past data. The computers learn automatically without human intervention, and they adjust the actions accordingly. The equation is formed accordingly. Is that clear?
Yes, sir.
Everybody, is that clear, guys?
Yes, sir.
Yes, sir.
We'll now go on to multilinear regression. Anybody would like to take a bio break? We'll take a 5-minute bio break. We will assemble again
Okay, sir.
at 6:15. We'll start
Okay.
again at 6:15.
Okay, sir.
It's 6:09 now, 6 minutes. Welcome back, guys. Can we resume?
Yes, sir. Sure.
Participants, please confirm, can I resume?
Yes, sir. Uh,
Okay, one more request, guys. Please don't use the chat box. I can't look at the chat box when I'm talking to you all or showing
Okay,
a slide.
okay, sir.
Okay,
I
sir.
will not be able to see what all are typing in the chat box. If I keep the chat box open, I will not be able to see what the slide is.
Okay, sir. Got it. Thank you.
So
Okay, sir.
don't use the chat box. Please use verbal indicators.
Okay, sir.
Okay, so now we are going to take a look at the multilinear regression. Sharing my screen. I have two two independent variables. There will always be only one dependent variable in whatever regression, simple or multi. Dependent variable is going to be only one. In this case, it's quantity sold. But what are the two variables? Quantity sold will depend on unit price as well as advertising. How is it dependent on unit price? Can we say, take a look at this? There is a exploratory data analysis, a scatter plot and a trend line created. As unit price is decreasing, the sales is increasing. Can you see that?
Yes, sir.
What is the R square?
Percent.
What is the R square?
43%.
Can we go ahead with such a low R square? What should be the R square?
At least 65.
Okay, so what should we do? If the R square is less, we cannot use that data for linear regression. But in this case, there is not one dependent variable, independent variable, but two independent variables. So we have to consider the combined R square. Is that clear? Not individual R square.
Yes, sir.
Here, this is giving us only individual R square. Let's go further. Take a look at the advertising now. Advertising. As we are advertising more, the sales is increasing. More the advertising spend, more is the sales. What is the R square?
60.
Very poor. But as I said, we will not consider this R square. This is R square of individual variable. We have to consider the R square combined of both the variables, unit price and advertising. Is that clear?
Yes, sir.
So what is the linear equation? Linear equation is y is equal to mx, m1 x1, m2 x2, mn xn plus c. In simple linear regression, we had very simple. Y is equal to mx plus c. Everywhere the equation was given in this format only, isn't it? Here is going to be a different equation format. If there are two variables, it will be y is equal to m1 x1 plus m2 x2. If there are n variables, there it will be mn xn plus c. So it can be really long equation if there are multiple variables. You can have as many variables as you want in linear regression. There are certain rules which we'll not go into at this point. But suffice to say, you can have many columns in linear regression. How do you find M1? M1 is found by this formula. How do you find M2? M2 is found by this formula. How do you find C? C is found by this formula. Anybody wants to try it? I'm not going to teach you. I'm not going to show you. I'll leave it for you all to find out how to do this. Frankly, I have not attempted it myself. R square, by the way, is even more complicated when you have more than one variable. So what do? We let Excel take care of it. We will tell Excel to generate a regression summary. It will generate all this. Before we generate the regression summary, we can find out the individual coefficient. This we already saw. The coefficient or correlation between the two, unit price and advertising, is important. If this is high, it means that these are correlated. We should not be taking both these features of columns for linear regression. What is the R square now? What is the R square?
0.76.
It is strange. It is strange, no? Individual R square is so low.
Yes.
But the combined R square is quite good.
Yes.
Can we go ahead with linear regression in this case?
No.
We can go ahead with linear regression because R square is greater than 6.65.
Okay.
Yes, sir.
There is another variable which tells us go, no go. It's called as probability of the significance or significance F. If the value of significance F is greater than 0.05, I repeat, greater than 0.05, then we should not go ahead. If it is less than 0.05, what we are trying to say is that the error is less than 5%. Then we will go ahead. If the error is greater than 5%, we will not go ahead.
Okay, sir.
Similarly, we will also check the p-values. P-values of intercept is fine. We will not check that. But of all the columns, we will check the p-values. If in case this is greater than 0.05, we will not consider that column. Can we consider both the columns here?
Yes, sir.
They are less than 0.05. So what will we do? We will create a linear regression equation. How do we create it? Can you see this? Y is equal to m1 x1.
Yes, sir.
What is
Yes.
what is m1? M1 is this, and x1 is this, whatever is in this column. What is m2? M2 is advertising coefficient
Advertising.
into the advertising variable, plus intercept. Intercept I've taken first. I created the equation and then copied it down. What am I getting now? I'm getting prediction for this. Do you want to see this in action?
Yes.
Okay. So let's start Excel and we'll see this in Excel. Close this file. The same data is here. We will use the prediction data. We'll copy it later up. Let's first create a matrix for the correlation matrix. How do we do that? Data, data analysis, correlation. Input range. I mark the input range. Labels in first row. Output range I will give as now I will generate the linear regression summary. Again, we have to use a data analysis tool pack. Some of you may not have it. Search the internet how to enable data analysis tool pack. It's very easy. Data analysis tool pack, regression, Y is the input range, X labels is there, output range, we'll take it at E. We will create this again. Data analysis tool pack, correlation, Data analysis tool pack regression is fine. I'm losing some data. That's why I'm do it again. Can you see this? Similar output to what was there in the PPT. We got it live. Now we'll work how to do the prediction. I start with the intercept, coefficient of the intercept plus coefficient of the unit price into unit price plus coefficient of advertising into advertising. And then I can copy it down. Sorry, I'll have to first make the part absolute F17, F18, F19. I have to make it absolute. Now if I copy it down, it should work well. I can take the same table and put it here so that it becomes very prominent. Everybody understood how to do linear regression in Excel?
Yes, sir.
It will take some time. You will have to practice. It will not come very easily. Initially, you'll get a lot of errors. For the students of the college, if 9mm organizes one practical session, I'll help you all.
Yes, sir, sure.
Here also, we discussed this slide. There is a new parameter that we have to check, significance F. Generally, when R square is good, significance F will be small. When R square is bad, significance F will also be bad. They go hand in hand. If the R square is good and significance F is bad, that means there is some calculation error. These are steps of linear regression when we are doing programming in Python. This is the Python output, similar to the Excel output. Again, we compare the R square and adjusted R square. We check the p-values and we check the coefficient.
Sir, your screen is not visible.
Oh, I'm so sorry. So we've done this. We've done how to do the prediction. We've done how to do the summary. We go to the next slide. We understood the equation. R square remains the same. The fundamentals of R square remain the same. We understood the new matrix significance F. That should always be less than 0.5. Incidentally, R square and significance F go hand in hand. If R square is good, significance F will always be good. If R square is bad, significance F will also be bad. In fact, if R square is good and significance F is high, there is something wrong with our calculations. There's nothing wrong with the data, there's something wrong with our calculation. Is that clear? This is how we do linear regression in Python, the steps which are taken. If you see the steps are identical to what we did in Excel. You can see OLS summary, adjusted R squared, check p-value, check RMSE, scatter index, identical to what we did in Excel. Even the output, the format might be different, but the data contained in that is same. Here also we check the adjusted R square, we check the F significance or F probability, we check the p-values. And finally, we check the coefficients. These are the coefficients. Here, if you see that there are multiple independent variables, not just two, but there are many. There can be even more than these. RMSE remains the same. Concept of RMSE remains the same. If the RMSE is greater than 100, we will use scatter index. I will now throw open for any questions. Would you like to ask me any questions, guys?
Yes, sir.
Go ahead.
Sir, if independent variables are more than 2, then we have to consider all?
Yes, we have to consider all, but then depends on the p-value of those variables. If those p-value of the variables is greater than 0.05, then we'll drop the variables and run the regression summary again.
Okay. These complicated,
Go ahead, Mayank.
these calculations seems very complex, sir. So what if we
That's
will
why I
not get
say we don't
the
need to.
actual data?
That's why I say we don't need to know the internal working of the algorithm. We should concentrate on just on application of the algorithm. For application of the algorithm, what do you require? You require R square. Do you know the rules for R square?
Yes, sir.
You require the p-value of each column. Do you know the p-value of each column?
Yes, sir.
You require knowledge of how to create the final equation. Do you know how to do that?
Yes, sir.
Do you know how to work with linear regression, apply linear regression in your requirement?
Yes, sir.
Do you know the internal working?
Yes, sir. Indirectly, we know.
Indirectly, you know, because we done it today. But if we had not done it today, you would still be able to work with those rules.
Yes, 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 sir. Yes, definitely, sir. I understood.
That's the point I'm trying to make.
Yes, yes, sir. Got it, sir.
So don't be afraid of machine learning. In fact, machine learning is very easy. And I say that with experience. After some time, machine learning becomes boring. Can you believe it?
Yes,
Because
sir.
you're doing the same thing again and again.
Yes, sir. Yes, sir.
So it will reduce the human efforts.
Definitely, it will reduce the human efforts,
Yes.
no?
Yes. As a non-technical person can also now get all the things in screen.
I would not say completely non-technical. You will still require good computer knowledge.
Yeah.
If you're working with Excel, you'll require good Excel knowledge. If you're working with Python or R, you will require knowledge of R and Python programming.
Programming.
So complete non-techie is no. Any other questions?
No, sir. From my side, it's okay.
Anybody else, guys?
Sir, please share your Excel sheet.
I will do that.
Yes, sir.
Okay, if there are no other questions, I'll hand over the platform to Naina ma'am. Naina ma'am, please take over. Thank you so much. Thank you, everybody. I hope you all had fun.
Yes, sir. Thank you very much, sir.
Yes, sir. Thank you so much.
And while having fun, you all, I hope you all have learned something new.
Yes, sir. Of
Yes,
course.
sir.
And most important, I hope you all have learned that you will not be afraid of machine learning.
Yes, sir. Not anymore.
Okay, Naina ma'am. Thank you so much.
Thank you so much, sir. Next, we have with us the next guest speaker, Mr. Vinay Porhade, sir. He is the founder and director of a startup AI Quest Solutions. The firm excels in data science and AI consultancy services. He is an artificial intelligence and machine learning expert and has been providing AI consulting for various industries or domains since 2018. He has been imparting the corporate trainings as a guest faculty on various topics in Python, AI, and ML. He has full stack software development experience and has been in the IT industry for more than 15 years. Most welcome, sir.
Thank you, Naina ma'am. I hope you can hear me loud and clear.
Yes, sir. Yes.
Yes, sir.
Uh, First of all, it's good to see that such uh, activities are done in the COVID scenarios. Otherwise, there is not much to do. Good to have learning as one of the activities to do in this COVID scenario. So it's great that we are having this and privileged to be on this forum. Um, so while I was listening through Sir's lecture, it was a great, insightful lecture, and it is very important, as Sir was saying, that these concepts need to be practiced. So what, from my perspective, I come from the industry where we deal with the clients day in and day out. We deliver these products to the clients. We consult. We do the consulting to the client, like how we should go around developing these products in various industries. So with last 1.5 or 2 years of experience, I can definitely say that you will need a good amount of expertise in three areas at least. That is, you need a good hands-on on one of the technologies that Sai sir was talking about, right? So at least R, Python, or at least Excel, you should know very well at the beginning stage. But Python and R is the go-to language that you should definitely care about if you want to uh, get into the mainstream industry. Okay, Python and R definitely. But Python is definitely having an edge these days. Uh, R is not much used as we are taught in the industry. R is mostly used in statistical analysis, but when it comes to high-end applications, right, industry-grade applications like computer visions and machine learning or natural language processing, chatbot creations, Python definitely is a good choice. So just to break the ice, I just wanted to let you know that yeah, definitely you should have some hands-on these technologies. Uh, and I will now go ahead with the topic that we have called computer vision. Uh, Naina ma'am, is it okay? Should I go ahead? I'm not sure. The earlier lecture, do we need any biological break right now so that people may, the audience may just take a small break and come back, or should I just go ahead and
So
start it?
you can go ahead.
I can go
You
ahead.
can
Yes, sir. Go
continue.
ahead.
Yes.
All right. Let me try and share my screen out, and I will give a very brief background about what we are talking about before I get into. I have 1 hour, so I'll need to be a bit quick. I have good amount of things to share out. All right. So what I'm sharing right now is not what I want to show, but this is something that just, as we were looking at the session, these three things before you go to machine learning and even computer visions, right? So there are certain topics that you definitely need to have under your belt before you attempt computer vision. So this is what I was talking about. So you should definitely know Python or R, but as I said, Python is the best language. So I would definitely encourage you guys, even the students and faculties, both to have Python. A bit of applied statistics. These are the topics that you should definitely encourage yourself to get acquainted with. And the machine learning concepts. I know all the machine learning concepts are important before you jump onto additional and higher topics like computer vision and natural language processing. These are your building blocks. I think regression was one of the topics that we were just looking. It is, if you see in a machine learning concept, is just one line in somewhere in the middle called regression. So there is a lot of the ground that students and faculties will need to cover before they graduate into deep learning and computer vision like topics. So these are the next level of topics. So once your background for machine learning is done, then these are kind of specializations, I would say, in machine learning that you can take. So deep learning is one mandatory aspect that you should understand, because deep learning itself means you will be learning neural networks, and I will be talking a bit about that as well too. Okay, computer visions are I mean, the backbone for the computer vision is neural networks, and that is specifically what we are going to talk about. And you will need to learn packages in Python called TensorFlows, Keras. There are topics like convolutional neural networks, recurrent neural networks, and so on, and transfer learning. And once you complete this deep learning aspect, then you go to computer vision. So computer vision will also need some packages to be learned like OpenC, glibs, and so on. We will talk more about it in detail. So I'll go step by step on all this. I just wanted to show you this is probably a learning curve that you might have to cut if you reach to computer vision, right? If I go back, this is what you'll have to learn first. So you will need to have the machine learning covered, all these machine learning concepts, and then come to deep learning and computer vision. So I wanted to ensure this because we are directly jumping from linear regression to computer vision. So it's not directly in line of your curve, but there is a lot of gap between the linear regression and coming to computer vision. Okay, so you have to understand that to really get through computer vision, you will have a good amount of learning that you have to cover in between. I will just cover a few aspects of computer vision, what you will probably learn into it, and I will try to share a few aspects that I have gotten for you. Okay, so give me a second. I will. Looks like I closed by mistake the session that I wanted to take. I know I have an hour, so bother with me if I'm going to. If you have any questions, you can definitely stop me uh, in between and ask me any questions or any doubts you have. Mostly, this is just an overview session that is going to happen today. I'll try to be as I'll try to pace it that it will not be too much overwhelming for you guys. But let me know if you have any questions in between. I can stop in between. Right. Let me know if you can see my screen.
Yes.
All right.
Yes,
Yeah.
sir.
Yes,
So
sir.
computer vision. Let me go ahead straight away with the topic introduction. Very basic. This is a bit uh, nerdy description. Nerdy description means it has too many technical jargons, but I will try to explain as much as possible as we got it. So the technical definition says computer vision is a utility that makes useful decisions about real physical objects and scenes based on sensed images. So there is too much in it, right? In just 2 lines, there is way too much in it, and that's exactly what we are trying to understand what it is about. So this definition was coined long back by Softman and Shapiro in 2001. In fact, if you really understand where this computer vision comes from, this is one branch of artificial intelligence. Now, if I have to speak about artificial intelligence, I think everyone here must have heard about that term at least, even if you are not technically aware what it actually means. But I'm very sure you must have heard about the term artificial intelligence. Now, the term artificial intelligence was also not coined very recently. It is there in this industry since 1940s. Okay, since 1940s or early 50s, there was some work happening in the scientific world to create a, a replica of a human brain. Okay, it's all about replicating human brain because all the scientists then even now today Western culture and scientists think that life happens in brain. Okay, you are alive because of the activities in your brain. So this is the theory behind all the artificial intelligence that is happening around. Okay, so whatever activity is happening in the brain, they are trying to map that activity. They are trying to understand that activity, how the brain functions, how the left brain, right brain functions. What are the different areas of brains that get activated when you are listening to music, you are reading, writing, driving, and all. They are trying to mimic that. So while they were trying to do that, of course, there were some limitations in 50s and 60s we are talking about, right? So there were limitations that we definitely know there was no internet. We definitely know there was no good hardware, right? So these two, also the programming languages like Python, it is that strong today. It was definitely, there was no strong programming language then to simulate the activities that go in brain, you're right, and in in a sophisticated manner that it happens today. It was not possible then. But today, it's kind of resurrected. So this AI, computer vision, machine learning, all this is not a new thing, right? It is resurrected because of the advancements in the technology that has happened since last decade in all the areas. So let it be hardware, be it software, be it packages in Python, because of the 4Gs and 5G technologies, the IoT technologies. So all that has made it possible again for the data scientists like us to do research in these areas and try those concepts again, try to implement those concepts again. So in theory, the science is there, but technology was not there. So this is the statement that it can make. Now the technology is also there, right? Science we already knew, but the technologies are happening now in the last decade, or in fact the last few years, 4 5 years. The technology has come like such a fast pace that implementing this logically in the computers, the neural networks, is becoming possible or fast enough to implement these tasks and applications that we are going to talk about. Okay, so with that background, so of course now you would say what are the functions in the brain, right? What these brain functions like? So the brain functions, basically these are cognitive functions that we talk about. So this is an important term. Okay, so the cognitive, let me write it down here if I can. Is it possible? Oh, no. Looks like I was trying to annotate and my Zoom collapsed. Let me share my screen. Okay, I may not be able to write it down here, but on the PPT. I hope you can see my screen again. My screen had stopped in between. All right. So we need to understand that all they are trying to do is mimic the brain functions or the cognitive functions of the brain. That is seeing, hearing, sensing the motion, smell. Smelling is yet to be discovered, or people are working on that. So there are no computers which can understand smell and taste. So test birds and your nose functions of smelling, the research is still happening. But the research has gone a bit ahead in computer vision, that is the robotic eyes, and the natural language processing, that is the power of speech, right? All the Alexas and Google applications that you see today are because of natural language processing. And this computer vision is one such branch that we are talking about, okay, in AI. Now let's try to understand what are the tasks and applications that we have in computer vision. Why I've divided in this in tasks and applications, this is very important because otherwise people try to mix them up. This is very important for people who are coming new in this world of computer vision. Okay. The first task that as a human being, if you look at what does our eyes do, right? Computer vision, what does human vision do? So they recognize the objects around us. They recognize, differentiate, or dissect the objects around us. We can differentiate different objects. Of course, someone has to teach us when we were kids, right, to identify or understand using the labels, the English labels or your mother tongue that you're talking about. But recognition is what basically you like to do or what you want to do. Okay. Motion analysis. Is some object stable or is it moving around? And if it is moving, where it is moving? This is mostly important for cognitive capabilities, like when you your sports are important for kids. This is why, because your motion is tested and developed in kids, right? So this is what is happening in the AI world as well. can you make robots catch an object which is thrown at it? Can it calculate the trajectory of that object that is thrown to you and so on? So this also goes on and extends to the missile technologies today. So if you want to send a rocket on Moon or Mars, what should be the trajectory? Can it calculate by itself and so on? Okay. So there will be a computer on board on that rocket that will see if the path that it is taking is right or not. Not what it is done today. Today it's done by satellites. This is completely different technology that we are talking about. Scene reconstruction. So this specifically is given you have a particular object from different angles. Can you develop a three-dimensional view of the particular object or a particular scene? This started this area was started we started working on this area in reconstruction for forensics departments. So forensic departments required these capabilities to you know uh, try and mimic the scene of crimes and so on. But this was not just used for forensics. Scene recognition reconstruction is also used for archaeological purposes now. If you are digging and if you find a half preserved artifact, you can reconstruct what the complete artifact could be with certain amount of accuracy. I mean, it's not have 100% accurate, but it's definitely very preserved. Image restoration. So these people, you might have heard that if you go in a lab today, if you take a very old photograph of your forefathers and if you want to reconstruct it, they can do that. So of course they use uh, laboratory methods of color enhancing and so on, but computer vision is also capable of reconstructing the image as good as it is would have been, or black and white images converted into colored images, without really processing on those images, without manual work. It is automated. So these tasks are supposed to be done by computers computers using artificial cognition capabilities, and computer vision deals in these kind of these kind of tasks that it is supposed to do. And what are the applications that, if once you are able to do these tasks, so there are these four categories of tasks you should be able to do before you apply these on real world applications. So what are those applications you think would be, right? So these are in the second boxes. So it's medicine. Of course, we'll talk more in detail about it. I have one slide for each of these, okay, that we are going to talk about. Machine vision. But medicine, of course, checking once you have the X-ray, examining the X-rays, examining the MRI reports, and so on. Instead of going to a doctor and he analyzing, there will be apps in future that will do it for you. Okay, we'll see one or two examples in our slides ahead. Machine vision. Machine vision means, let's say your manufacturing plant itself will have cameras installed inside it, and they will monitor how the machine is operated by the workers. Are the safety measures? Uh, is everything safe right now at the real time that it is being monitored? It is worked on, right? That is what machine vision is. Military, of course, we know we need radars, we need border patrolling. So we are spending so much in military. Uh, Good amount of good percentage of part of GDP of any nation goes into securing their boundaries. With computer vision, I think that will be safe and also cost effective, where you can install computer vision based security appliances. We'll talk more about it in later. Okay. Autonomous vehicles, I think, is very famous. We all know about it. There are driverless vehicles being tested in US, UK, and many Western countries, and at the heart or at the core of the technology is computer vision. Okay. So tactile feedback, this is one important aspect that has come up very recently. This is specifically looked on for handicapped people, where you do not, where some people have lost their eyesight, their hand movements, the motions, right, or hearing capabilities. So these computer vision can help create devices which will give a tactical feedback to you, that it's like using robot for surgery, remote surgery. This is what we're talking about. You must have heard in news last year that there was a surgery done by a doctor in India and the patient was in US. So the robotic hands did surgery, and the robotic hands were, operated from this part of the world in India. And that's what the tactile feedback is. Now you have to understand it's not that easy to operate. Someone is not you are looking at. So there are various different constraints that we will see and how it is done. So, okay. Now let me go ahead and start talking about each of these line items that we're talking about. Recognition, right? So recognition, what can we recognize today? If we look at computer vision today, what can we recognize? We can definitely recognize face. We can recognize postures. We can recognize emotions. We can recognize characters, alphabets, digits. Now, this all is possible because of neural networks, and I have specific slides that I'm going to speak about later. This is the slide that I'm talking about. Okay, so you can recognize the face, posture, and character. All right. Now, there is too much of details that might get to be covered, to explicitly tell what are the steps in the face recognition process, how step by step, then what is the mathematics behind, what is the technology behind. But with the interest of time, I'm going to skip it. Maybe in the question answer session, if you have any specific doubts, you can ask about technical details. Okay. In just in on and just a brief overview, if you have your raw image, you detect where is the face portion. So that is the first step. So you crop the face, you detect, okay, these are the pixels in the image which are face. You normalize the image. Normalize means you sharpen certain edges, you sharpen the features of your face, that is eyes, eyebrows, ears, nose. Okay, that is the pre-processing that you do. You extract the features. This is where all the mathematics happens, right? Even neural networks are mathematical based models. So there is nothing else that happens behind the scenes but mathematics. Okay, and then you reduce the dimension, and then you find out this image is close to which of these two images. So these are gallery images. Gallery image means there are certain images that are stored in your database, and you're saying this image is closer to whom? Which image is closer to the raw image that you're looking at? So it will tell you the probability or the distance. And this is also called image classification. So this is what the steps are behind, how the neural networks work or how your computer vision works behind the scenes. Okay. So second example here, of course, if I get chance, I will also show you an implemented code for this, how the digits are recognized. Okay, there are handwritten digits which can be recognized or trained. The neural network can be trained to identify what this digit is actually. Is it 17600? So we have reached the science and technology has reached to a stage where it can definitely identify this. This example here on the bottom left is it can understand the facial features and the emotions by understanding the, you have to extract the features. If you see these dots, each of these dots, right? These closed shape of these dots is called a contour. These contours are identified in these images, and the distance between the open eyes, the closed eyes. If you see the lips here, so the right hand side, the person is smiling, or the left hand side, there is no emotion. So what usually you do is you recognize these features and you look at the aspect ratio. You look at the ratio between the lips, whether they are open, close, and the horizontal versus the vertical distance, right? And you try to find out whether the person is smiling or laughing or these emotions. So this is how the emotions are detected using computer vision today, right? So this is very fascinating. The research is still happening. It's not that perfect, but there is a good amount of research going on. Quite some accuracy has been achieved so far. And so on this posture detection. So if you see, posture detection is nothing but it is understanding how the skeleton looks like for that particular person. So what activity that person is doing can be determined using posture detection or pose detection. Is he trying to jump? Is he trying to dance, he's bicycling, he's running, he's walking, he's sitting, he's sleeping. So all that you can understand by this. That's what recognition is about. Any questions here on this slide? I mean, let me stop at each slide and have you ask me questions.
Yes, sir. Sir, I have one question.
Yes. Yes.
Sir, this handwriting images can we convert into the actual text?
Yes. So that's what I, in fact, have a code that I will show you. I will run that code and show you. It's not 100% accurate, but it has to be trained very well, and then it can definitely do some better job.
But sir, there is everyone is having the different handwriting, no?
Yes, that's exactly why it is fascinating, right? So
Yeah.
What is happening is, so I'll tell you how this is done, how the neural networks are trained. So basically, you have to train with thousands of people's different handwriting. So that is the difficult part of training a neural network.
Yes, sir. That is I'm asking.
So you have to collect those many handwritings. So good thing is there are free data sets available on internet.
Yes.
Okay,
Yes.
called MNIST, and I'll talk about this. So these
we
data
can't-
sets you can use and
yes,
train on them.
we can't get accuracy, na? Means 100% we can't get.
You can, but it depends on how many different types of handwritings you are allowing
Okay.
your neural network to learn.
Okay, sir.
So if I give only 10 people's handwritings to learn, it will learn that, but the 11th people it may not recognize. So instead of that, if I give, say 1 lakh different people's handwritings, right?
Then it may be possible.
Actually,
Yes.
then it is possible. Yes, of course.
Yes.
It is actually Google, Facebook, and Google have deployed their models which has close to 100% accuracy, 99.9%.
Okay.
So they can recognize alphabets and digits up to 99.9% accuracy, even faces. Face
Okay,
they have reached to 95% accuracy today. Okay, so it's a fascinating world. So this is a new there is a long way to go. I'm not saying that the work is done. Of course, you have a valid question there. How is the accuracy? But there is a long way to go. But we are reaching there where these can be used. These techniques can be used in real world scenarios, and which are being used in real world scenarios. We will talk more about it. Any more questions on this? That was a good question. Accuracy with machine learning is just not about neural networks or computer vision. Any kind of machine learning, the accuracy is always going to be a constraint, because it depends on how good data you are passing it for the machine learning algorithm to learn. Okay, if you give a good variety of data, it will learn well. Otherwise, not. That's always going to be the constraint. Second is the motion analysis. So this motion analysis can be of any object or person, right? So here now what we are trying to track is motion analysis of humans. Sports analytics is very widely already using it. Okay, mostly in football world, football and volleyball. Cricket, they have just started using it, the analytics, but football they have really went way ahead. So what the images that I'm showing is the actual training process that is happening using computer vision. They actually can predict what is the next move the opponent is going to make real time. Okay, the images are processed real time behind the scenes. There is of course, there is a lag of few seconds because of the relay mechanism of the live telecast, but you can definitely forecast. So the coaches can actually analyze how the opposition is playing, and you can tell your players that you should play with this strategy with this particular team, right? Different teams have different strategies. So this is what is used in sports analytics. They actually can predict using computer vision how these players are moving and what is the strategy they are using. Very fascinating here again. And of course, you can see on the volleyball side that they are playing the basketball. Sorry, you can see what every person's moment is. Is there any action? If there's no action, you're walking, you're doing a defense, right? You're passing, you're who has the ball in hand, and so on. All these things, computer vision is definitely able to identify. This is a real output that I'm showing you. This is not done in paint or anything. This is actual output of a neural network in action. Okay, this is possible today. Many people are using this kind of techniques in sports. Motion detection can also be used just not in sports, but also in for the security of the premises, your offices, your homes, your society complexes, right? is there any unlawful activity happening or any one intruding you the premises? If there is a person which was not supposed to be there in that room, but you see a person sneaking in, in a data storage room and so on. So on this left bottom image here, it definitely tells you that how it is done today. So if there is a person walking in, it will get highlighted here, on the right hand side. If you see everything is black and this person's image or an aura is highlighted. So this earlier it was done using thermal imaging. So it's not that only computer vision can do that. The infrared cameras, infrared devices, the thermal imaging used to do that. But there were ways these intruders were able to circumvent this ways. But computer vision does not work on these philosophy of heat maps, right? Computer vision is what it sees. What you see is what it tells you. It is going to be very, very interesting to see how far ahead we go in security kits. So definitely many industries have started using for their office securities and all, but the public domain has yet to adopt it, or the government offices are yet to adopt it. So let's see when it happens, especially in India. Motion detection is very heavily used today uh, in social areas like malls. Now, especially now, I'm saying where this is very heavily used in China. So we are very well aware that China is light years ahead in computer vision than any other country today. Not even US, not even Japan. So China is the quite ahead in the technology of actually using it, because there is no civil body to oppose them. Basically, if you want to install these cameras and track your motion throughout the mall, the citizens will not enter that mall, right? Because you are tracking them if they know it. But in China, there is no such laws which are protecting civil rights. So they are okay to do anything that they like. So, but because of that, China has developed their artificial intelligence, especially computer vision, to such an extent that they have it will take many years to reach to what they have done today. And these are really images that they have shown that what technology that they have today. Okay. So let me go to the next slide. So, and any questions here on the motion detection part? No. Okay. Let me go ahead.
So what is this umbolite?
Umbolite, yes, it's like this is just a technique. This is just a different technique, right? Where umbolites were used to detect the heat maps and so on. Right? Motion detection, on the other hand, uses true images. It doesn't need any other apparatus like umbolite. Umbolite is, it's just a frequency of light, right? X-rays and so on. So it detects using those different ways. So here, computer vision does not need anything. Just a very basic apparatus, just a very basic camera, you will be able to understand what the motion is. That is no fascinating. It's like very less cost will be required for that. All right.
Yes. Okay.
It's just a comparison between umbolite and motion detection. All right. The third one was scene reconstruction and image restoration. Okay, so these are the two restoration aspects. So on the left side is an archaeological survey example where there were few photographs that were taken and they reconstructed a 3D image out of it. So these kind of reconstructions also can be done using computer vision technology. So this is bit in the primitive stages today, the actual 3D dimension reconstruction. But this particular aspect of 3D reconstruction of your world around has taken a completely, it's a different branch now. It's not, of course, it comes under computer vision, but it's now called augmented reality, if you have heard about it, or virtual reality. So augmented reality, virtual reality, you get the virtual reality glasses, the video games are coming, that gives you virtual experience. So there is a different branch of computer vision called augmented reality that is coming into picture, and that is a whole separate career to today now. That is also very fascinating to recreate your world in digital world basically. So this is just primitive example. There are even better examples if you search augmented reality in Google or virtual reality. So this image restoration is, so if you see, humans can identify. So humans can see on the top image that there is a lot of noise here. You can identify 2857 is here, but can computers identify? So that was one of the ideas of computer vision using neural networks, specifically something called autoencoders. There is a technology called autoencoders in computer vision now, which has made it possible that you can train how a digit 2857 looks like. We have seen that earlier. Now you can reconstruct it, right? So from these garbaged or garbled images, you can reconstruct these images to fair amount of accuracy. Of course, it won't be very accurate, but it understands, okay, there is 5, 7, 2, and 8 here. So this image reconstruction restoration is possible. Even the handwritten digits, handwritten characters, these restorations are possible. Now, even not just the handwritten digits and characters, but also the actual picture restoration is possible. Let's say if you have some person's, let's say hundreds of images. This is what Facebook has doing. Facebook already has this technology. Okay, so Facebook has hundreds of images that you have uploaded yourself on their database. Correct. So what they have done is they have created these facial recognition engines or neural networks, which can not only identify and tag you in those images, but also, let's say you are wearing a mask in these COVID days, right? It can it can actually detect that who is wearing that mask, even if half of your face is not visible. Still, it can reconstruct your face and say, okay, this is that person. Okay, that's what reconstruction we are talking about. It is possible. Facebook and Google definitely have this capabilities today, and many of the startups and some small scale AI and data science startups have these kind of capabilities or doing research on this kind of capabilities. So this kind of activity or task is also possible in computer vision. Any questions here on this slide? All right, let's go ahead. So these are applications. So if you remember the two boxes that I had shown, the tasks I have shown, now these are the applications where they can be used. Now, this specifically comes into the world of convolutional neural networks. There are types of neural networks where a pre-processing kind of action happens before the training is done. So what it needs is, it needs labeled images like this. So it needs images like this. So this image was taken for some patient, and you need to know beforehand that that person had pneumonia. So these are historical images of it, and this person has COVID and something like this. Okay, this person has cancer, this doesn't. These are the process images. This person's bones are broken, there is an arthritis, this person does not have arthritis, and so on. How does computer understand that? What basically it does is, there is a neural network that is trained behind the scenes. It is passed hundreds of thousands of images with this labeled data, that this is an x-ray of a person and this person has pneumonia, this is a x-ray of a person which has COVID or detected positive COVID, right? And so on. Or there will be such categories that will be trained with lots and lots of such images, and it will be tested against some known patients. Okay, there's some patient, let's say you have to predict now, right? So you will take someone who has already identified COVID, and it will the scientists will test, okay, is your neural network really giving a positive uh, result or not? Positive means if there are type 1 and type 2 errors, right? So in any classification, there can be two types of errors, that a person has COVID, but your network is showing it does not have, and vice versa, right? And in both scenarios, the neural network has to work well, right? It has to segregate out who does not have COVID and who does have COVID today, or pneumonia for that reason, whatever it can identify. Okay, why this has been happening now? You will see that we already have the technology to identify pneumonia and COVID using X-ray. So why are we doing? Because of the time gap between the X-ray is taken and your whether that you're told that whether you have a particular disease or not, or you have lung disorders or anything. There is some amount of time that goes by before the actual report comes out. That can come down to literally 2 seconds. Now, this is what one of the machine learning engineer who is working with the medical association in US and China. Both they are working on this mainstream applications of this. So it's not just in books now. In pathological departments will actually start using these techniques as a first level of detection. So your neural networks and computer vision can tell you what is the probability that you may have COVID. So of course you need to have to take swabs of your throats, nose, and saliva, right? Of course, without that, it is just by looking at lungs X-ray, it's not going to tell you 100%, but at least it will give you that head start that you will start being medicated. So you don't have to wait for 2 days or 3 days today for COVID if there was a neural network, implemented. Now, it is easier said than done. So it is fascinating world. It is easier said than done because hundreds and thousands or hundreds of thousands, I mean, I would say millions of such images need to be fed to the neural network to come to good accuracy. And while the medical association is battling with the real scenarios, providing these labeled data to the data scientists is going to be a challenge. So I'm not sure if this is going to happen very soon. But in near future, I'm very positive that medicines and medicinal purposes of computer vision is on the card. Okay? Many researches are happening already on that, especially in dental as well. And hopefully next 5 years in India itself, you will start seeing uses of computer vision in medicines and so on. Okay. Any questions here? Should I move ahead?
Yes, sir.
Machine vision is another. This is already happening in India. Okay, machine vision is already adopted by many big scale industries like Tata's and Reliance's. It is already happening, especially automobile manufacturers, bottle manufacturers, and so on. These are the real images that we are seeing. Okay, machine vision is used mostly for safety reasons. So if you see here in the first top left, first quadrant, there is an image which identifies, again, object detection. There is nothing different than what we had seen in those tasks, right? We are doing nothing but we are identifying the object. We are identifying that is a human, right, in your workshop. And what is he wearing? Is he wearing hand gloves? Is he wearing elbow caps? Is he wearing knee caps? Is he wearing a mask? Is he wearing a shield, eye shield? Correct? It detects all that. So of course you must have seen mask detection examples these days floating around, right, on YouTube channels and so on. Similarly, but this is more advanced. So it actually real time tells you that all the safety equipments are being, put on by the worker. If it finds out any person does not have the safety equipment, it sounds a buzzer or an alarm. It actually sounds an alarm. So this is very widely used in Japan and Germany today. India, of course, it is being used, but not very widely. It is used in big scale industries, not in small and medium scale industries. Right? Now, second is sorting. Yes. Yes. Yes, you have any question?
Yes, sir. Like the expressways or in the long routes, I think many of the places are
I'm sorry, I couldn't hear you. Your voice was breaking. Is it me or I don't know? You can hear me well, right? I'm sorry, I couldn't hear you at all. I mean, I could hear very, very. Your voice was breaking a lot.
Yes, sir. This voice is
Yeah.
breaking.
Yes. You can type your questions as well if there is an issue with
Yes.
your mics. You can
Sir, you
type.
can type your question in the chat box.
Yes. I'll just go ahead by the time I get a question. So I got a few keywords. I know what the sir was talking about express highway, right? So I'm not sure what exactly the question was. Is the question about the accident detection and so on? So if there is an accident that has happened, or there is an object that is lying in the middle of the road, yes, it can be used. But the thing is, uh, the cameras need to be placed at every specific 100 meters intervals and so on. That might become costly. So, so we need to also understand that such a wide scale use of computer vision, there is a cost impact is there. So if government is ready to bear that cost, these technologies are already available. I mean, these applications are already available. Deploying it, see, deployment is another big challenge. If you want to deploy this technique to identify if there is a if there is something out of ordinary happened, okay, we categorize it as out of ordinary, or an outlier. Is there something outlier? There's something happening which is not supposed to happen on the highway. Maybe it accident, maybe someone is stopping there, some motion detection. Yes, it all is possible today. Only thing is the deploying those technologies really on the field is going to take some time, for especially for countries like India, because of the cost constraint. But it is absolutely possible. I mean, in laboratories and in some small areas, these have already been tested out. Okay, absolutely possible. So safety. So there are two images on the left, bottom and left top. These two images. So bottom there is a barrel, which is lying down. If you see, this barrel may be having inflammatory liquid, right? So if you see the liquid is spilled from that barrel, so it may be dangerous for people who are going to come, or it may catch fire, something like that. So it might sound an alarm, right? These kind of technologies are already there. They are being used in industry. So only the big scale, wide scale application on the streets is a constraint. Okay. The safety measures in manufacturing industries are definitely being taken care of. Sorting is very important. So let's say you today have humans to sort different shapes, sizes, and colors of the raw materials that are used in the manufacturing today, right? But now robots can be, it's a human using the computer vision and the robotic arms, you can make the sorting process much faster. And it's not about making it fast, it's not about making it cost effective, it is about quality. So it's all about quality assurance. If you have the right sorting process, your quality of your products will be very good. It's not about reducing the workforce or something. There are many people who ask, if this comes in the industries, then what about the jobs? Nothing will happen to the jobs. This is just a sorting process. It will aid the humans in sorting. It's not that it will completely replace. Okay, at least not for a few more decades. We do not have the technology. All right. Counting. So if you have these bottles that are, let's say, distillery bottles or aquafina bottles, if you see, it can actually count. So there is neural networks that can be, this specifically happens using OpenCV packages. You can actually count the contours, these like round shapes of particular color. So white and blue shaped white round shape. So this is what computer sees, and you can count them. And based on these, you can actually make your counting process. So this is making your process faster. Okay, this definitely needs to be faster. Counting is a very slow process. And if you're manufacturing millions of bottles every day, counting needs to be very right. So computer visions can definitely help you to count better. All right. The questions. Was there any more question about apart from uh, the highwayman? Anyone has any questions on this? All right. Let me go ahead. Autonomous vehicles. We of course have already uh, seen the news that Tesla and Google and Facebook, they are testing their own versions of autopilot or automatic vehicles that will drive itself, driverless vehicles, as we call in India here. So of course it uses computer vision, object detection, image segmentation, and all these techniques. So while a vehicle is driving, it needs to identify all the possible objects and also make sure it is driving in its own lane, stopping when it needs. needs to understand the signals, needs to understand the activity around. It's not easy at all. Okay. On the right hand side, you see right top, you see all the objects identified, right? Sky, building, pole, road markings, the actual road, the pavement, the tree, the sign symbol, the fence, the vehicles, the pedestrians, the bikes, all this it has to identify and take real time decisions whether to speed up, whether to maintain the speed, whether to stop. It's not easy at all. But I think it has reached a good amount of accuracy that US companies in US like Tesla and Google's have definitely gone way ahead in this technology. This especially is needed for the vehicles that we send on extraterrestrial planets, right? Like Mars. So Mars rover. So this example is of Mars rover. Now you will be uh, excited to know that the Mars rovers works on Python 3, especially computer vision, TensorFlow, Keras, right? All these Python technologies, all these Python packages like NumPy. It uses this to identify objects and move around the Mars surface. So Python is officially used in that. So if it can do that, then definitely it can do many different wonders, right? So, and there is no, it's so you have to understand that no one is remotely controlling this Mars rovers from Earth. Okay, it takes its own decisions, and that's what is the best example of natural language processing or computer vision. Sorry, not natural, deep neural networks. Okay, so there are neural networks that are kind of neural networks introduced or kind of installed on these devices that are sent to Mars, and they take their own decisions, which direction to move, which object to examine, and so on. It's very uh, good tech to understand how you can do this simulation on here as well in the labs if you have right number of devices with you. All right. Tactile feedback. So this was what I was talking about. So you have devices today which can help you, which gives the feedback to the actual device, which may be kilometers away. So someone is there is a robotic arm, let's say, and it is trying to touch something, some object. So whether that object is hard or soft, or what is the texture of that object? Is it smooth? It is rough, correct? Is it acidic? So you don't want to touch something which could be acidic. So it just gives you the feedback to the machine, and the machine tells you. It analyzes the signals and it tells you, okay, this probably is uh, made of a different object. So if you want to do an experiment at home, of course you can close your eyes right now. Just have one, just have two glasses, one glass made of plastic and one of steel. Okay, you can definitely, you don't have to look at it, you can just sense it by touching it, right? So these are the technologies that are coming, but using computer vision. Now this is what might confuse you. You might just look at a particular object and sense that it is made of plastic or made of glass just by looking at the texture and color of it. So that is what is the difference. Instead of just feeling with your hands or sensing it, just by using computer vision, you can have a tactile feedback, okay, of the texture of what it is made of. It is a bit, there is a bit of time for that, but uh, we are progressing in that scenario. All right. So this was I had. So the next section I can talk about is what is the actual technology and the mathematics behind. Let me know if you guys are really up to it and interested of, or if you want a small break, you can take a small break and then join, and I can show you exactly how the biological neuron is converted into an artificial neuron in mathematics. You guys need a small break? We have 20 minutes. You can take a small 5 minutes break. Otherwise, I can continue on that.
I think we should continue.
Should continue? All
Yes,
right.
sir. Yes, actually.
First of all, I'm not sure how many of you feel that this is going to be relevant for you, but I'll just walk over this without going into too much details. These are all technical details. So this is just an example here. This particular slide talks about how your actual brain cells, the biological brain neurons work. So there are these this is a biological neuron. There are these tentacles like things that are forming. These are called dendrites. This is a central kind of processing unit where all the dendrites are connected. If you see a nucleus here, and there is an axon which connects to another such neuron. So there are links that are connected to other neurons. So each of these dendrites connect to other neurons. So there is a connection of these neurons which exchange electrical impulses, right? And certain areas are activated, certain areas are not, depending on what is conducted, what kind of input is given by the sensory organs, right? Eyes, ears, nose, and so on. Now, this is what they wanted to simulate in a technical, logical, or a mathematical world. Okay, so they reconstructed it, right? And this is what exactly they talk about. So they say the inputs is x0, x1, xn are inputs. Now the inputs to this neural network is always numbers. Okay, it does not understand alphabets or anything else. Right? It understands numbers. Okay, negative, positive, any numbers, because it's going to be linear algebra. The equation it forms is a linear algebra. Okay, now just an hour back you saw linear regression, right? This artificial neuron actually is not doing anything apart, but it is actually performing multivariate linear regression. Okay, if you look at the equation here, so y is equal to w0. So this looks like y is equal to mx, right? Y is equal to mx plus c. So it is an equation of a line. So internally, there is a deep neural network that forms where each neuron will actually perform kind of linear regression using machine learning and finds which are the right weights that satisfy the equation. Okay, so there is an equation y is equal to mx plus c. You want to find m, right? That's what your aim was, to find a slope. That slope you can understand this w0. These weights are nothing but the slopes between your output and your input. See, all that machine learning does, irrespective whether it is neural network or any other machine learning, it tries to find out the relationship between the inputs and output. Okay, so you know the output, you know the input, and it tries to find out the relationship between them. And these weights balance the equation. It's like solving an algebraic equation, right, in your mathematics. So this is all what it does. That's what this artificial neuron is built on. Okay, so it's mathematics. It's core and raw mathematics behind. Okay, that is called this processing unit. So there is a lot of things happening. So there is a activation function and all this. So if you are interested, you can go and Google and check about what exactly this mathematics is about. Okay, or you can reach out to me separately and I can guide you how to get this knowledge, where which channels you should look on YouTube and so on. Going ahead, so this is how it looks in detail. Okay, this was introduced by Frank Rosenblatt in 1957. Okay, so this science, this architecture was there available 60 70 years before it was available. Only thing was the implementation, because of speed, the hardware problems, the connectivity problems. This was we are not able to implement it effectively. Now we are able to implement it effectively. Okay, so the smallest unit in a neural network is called perceptron. So what is a perceptron? It's an algorithm for supervised learning of binary classifiers. That's it. Okay, it is a supervised learning algorithm for binary classifiers. That means it tells you between two categories, dogs and cats, something like that. Okay, so this algorithm enables neurons to learn and process elements in the training set one at a time. Let's say you have two inputs, A and B. Okay, and there is a logical function which multiplies your A with the weight, right, and sums them. So it is actually a sum of products that you perform. Okay, dot product, and then it gives you output. So this is one perceptron. That's it. Okay, and under the hood, if you open this up, this is what it has. So these are inputs. So it has n number of inputs, right? The inputs can be anything, any features, right? and they are connected to this output function, right? Here, this multiplication happens. So x1 w1 plus x2 w2 plus xn wm, right? So that is sum of products plus bias. So y is equal to m1 x1 m2 x2 plus m3 x3, right? So it is multivariate linear regression. This is what this particular cell does. This does multivariate linear regression. Additionally, there is an activation function to convert the linear output into a non-linear function. This is what it does. The output is come. So up till here, right? So the inputs multiplied with the weights converted into sigmoid-like function. Output you get, right? This is an output that you get after multiplying some random weight. So these weights are randomly initialized. So let's say there are some inputs and there is an output expected. It is a supervised learning, remember. So you already know what is output expected. You are trying to balance the equation, the left-hand side of the equation and the right-hand side of the equation. And imagine these weights are like dials. So you are trying to change the numbers on these dials and balance the equation on the left and right side. That's all that the neural network does. Okay. There is something called backward propagation and optimizers, which changes or adjusts the weights in every iteration such that the error in the output, expected output and the actual output is close to zero. So this is all that it does, and that is explained in the next example here. Okay, it's the same explanation. If you see this equation here, W0 plus W1 x1 plus W2 x2 plus W1 xn, this is nothing but multivariate linear regression example. Okay, so it was good that you just saw linear regression just before this. So this is nothing but linear regression, this part. So activation function is, this is a logistic or a sigmoid function, 1 upon 1 plus e raised to minus z. Okay, so it gives you this probabilistic equation. If you see this S-shaped curve, so your inputs and outputs, right? It gives you this probability. What is, if a particular input is given, it tells you the probability. Let's say you are giving the inputs and you want to find out whether it is the image of dog and cat. So it will identify the height, weight, color, and so on, the characteristics of that animal, and tell you the probability whether it is dog and cat. So this is all that what it does. Okay, this is the architecture behind this. Mathematically or algorithm perspective, it uses gradient descent algorithms. So again, these terms I'm telling, I cannot go too deep into that. These gradient descent algorithms are the backbone of neural networks. How these weights are adjusted and so on. You should definitely read more about it. Okay, there are learning rates and net weight, old weight. So new weights are calculated based on the old weights and what was the error in the earlier example. Okay, so all it does is, so this is a trial and error method. Look at this as a trial and error method. This is trying these weights. There is some error. There is lot of error. So again, change the weights so that your, the equation is balanced optimally. So this is what the trial and, so that's why it is called machine learning. Machine learning uses trial and error method to solve the equation. Okay, this is what it does. This is the mathematics behind. This is how you can visualize the neural network. So you have three specific layers, this input layer and output layer, and there are neurons. So this, each circle is that perceptron that I spoke about. So this perceptron, right, this logical function, this input A, B, right? This circle is this, each circle here you look at now, right? So there are so many perceptrons connected to each other. So that's why this is called a fully connected architecture. If you see, every neuron in this layer is connected to the next layer. So this is called deep neural network or fully connected architecture. So what happens is the input comes here. So if some numbers will come on the left hand side, x1, x2, x3, x4, right? And these connections, right, these lines that you see, you can say that these are weights. There will be some number between -1 to 1 assigned to it. And you will have some random numbers will be assigned to it, right? You will do all this mathematics, the linear algebra, and find out what is the output that is coming, y1, y2, y3. Okay, and you keep on doing it over and over again until you get the expected output. Let's say x1, x2, x3, x4. It was, let's say you are trying to train that this image. Let's say there is an data that you're passing of animals, right? Cat, dog, and tiger. and you're passing the features of a cat. So until the output that you get is for cat. So let's say the first output node here is for cat. So you will get 1, 0, 0. Okay, 1 is for cat, 0, 0 is for dog and tiger. So until it gets it, it keeps on changing this weight so that the equation is balanced on the other side. Okay. So in other words, it is doing nothing but finding the right weights which finds the relationship between your input and output. This is all that does. Okay. And this is how convolutional neural network will look like. So you have a fully connected layer, output layer, but this pre-processing is something that happens. So there is a convolution that happens. Convolution means scanning an image. An image is scanned like a human eye would scan a scene, right? So similarly, an image is scanned by computer pixels by pixels. It creates some features out of it, and then it passes to this neural network, and then you identify, is it a car, a bus, a train, plane, or ship? Okay. This is an example of a convolutional neural network. This is how it will look like. There is another type of neural network. So basically, convolutional neural networks is kind of a backbone for computer vision. So this is how it looks at the images. So this one image tells you how computer vision works behind the scenes. Okay, it uses convolutional layers to pre-process your data, find features, and then learn using this mathematics, the linear algebra. All right. There is.
Describe the pictures also, no? Describe these pictures.
I'm sorry, I can't hear you. Well,
we can describe the picture also.
yes,
That,
yes, yes.
correct, na?
Yes, yes. So it is called image captioning. So you can give a scene, and it will say that, it will actually label this image saying car standing behind a sunset, something like that. So you see a sunset behind, right? So it
Yes, yes.
identifies what all aspects in image. So it is a scenery, there is a mountain, there is a valley, there is a road, there is a car. So it will image, it is called image captioning.
Yes, yes, yes.
Yes. So that these are image captioning is a process used for labeling the images automatically. Actually, you're creating these output labels for these images. Earlier, humans used to do it, right? So let's say there are millions of images. You have to pass it to this neural network. Now imagine that. You have to give, see neural networks is supervised with machine learning model. Okay. So you have to, along with image, you have to give the labels as well. Now it is a very tedious job to look at this image, give a label, and then give to neural network. So what they came up with is they came up with another version of neural network which will help in captioning itself. Okay. So first the captioning neural network will use, and that image with caption will be given to this neural network, and then it identifies all the objects in that image. So two levels of steps, so two steps happening one after another. Okay. First image captioning happens. That image caption and the raw image is again passed to neural network, and it identifies the objects in that. Okay, this is actual usage of the image captioning. So image captioning is not the final product. It is actually an intermediate product. The actual image caption goes as an input to the neural network. This is what I mean. Okay. Yeah, that was a good question. Thank you.
Okay.
So there are even more sophisticated architectures I can talk about. Along with convolutional neural networks, you can have recurrent neural networks, long short-term memories. These are architectures in neural network. These are not just mathematics. So this is what I was talking about, image captioning. Okay, so this is what CNN LSTM. So there are giraffes, right, standing. So this kind of architecture will identify giraffe is standing. Okay, so this is your example that you are asking for. This is image captioning.
Yes, sir.
So image captioning is also a well-known application today, but it is actually, this happens and then it is given to this neural network to identify objects. So it is an intermediate step. Right? So I think I tried to cover as much as possible in 1 hour. I know it was a short time, but I tried to make it as easy to understand without too much of jargon. That's all I had, everyone. So I think there are 5 minutes left. If there is anything that you have to discuss, any questions, any comments.
Yes, sir. The session was very nice, sir. A very informative session it was.
Sir, this last example that you give, is that related to content-based image retrieval of the Google? Means I don't have the actual idea.
Yes.
But I think like.
Not exactly. Not exactly. This is not the exact. This picture is not what is used exactly. There is even more sophisticated neural network that is created by Google, which does that. They have their own proprietary neural network.
So can we study that?
Google, yes, there is something called Google Net. The architecture was called Google Net.
Yeah.
Let me write it down. Let me see if I can. Or let me.
It's okay, sir.
Google it, right? I will just quickly Google and show you. So there is something called Google Net. If you type Google Net architecture, this is Google's own neural network. So you can go here and definitely learn about it. So what it is used for, how exactly, what it uses internally, what is the architecture look like, and so on. So this is a convolutional neural network. So before you understand what this table talks about, you need to understand what convolutional neural networks are. So what is a CNN? You have to start with CNN. What is CNN? What is a convolutional neural network? Once you know that, then you'll understand what this talks about, convolution, max pool, and all. These terms mean something. Okay.
Thank you. Thank you very much, sir.
Yeah, definitely you can go here and learn about it, but there is prerequisites before you start understanding all this. See, this is the architecture. If you look at this diagram, so this is a big, huge architecture. Google Net is this neural network.
Okay, sir.
So they explain, there are some websites which will explain step by step, even mathematics behind it. But prerequisite is you'll have to understand what is a convolutional neural network. Okay. You have to first understand what is a deep learning first. What is deep learning? What are perceptrons? The architecture, and then convolutional neural networks, and then go here. All right.
Yes, sir. Thank you very much for this detail, sir.
No, anything else? We still have 2 minutes. I'll just paste this link. So I'm just giving the first link that I got. There are many more examples we'll get on the internet. I just pasted this link. If you are interested, you can look at it. All right. If there are no questions, I'll give it back to Naina madam. Over to you. Or if there is any panel available, I'll just hand it over to you.
Thank you very much, sir, for your wonderful explanation of all the details. We had heard of all these things, but we were not knowing the actual things behind this. Now we would be getting more detail, as it was a coincidence that linear regression also got clear today, and the future things also are getting a bit clearer to us, so that we can study, and we'll surely get back to you whenever we are going to be in the trouble for understanding the thing. Thank you very much, sir, for your continuous support.
Yes, absolutely.
Thank you, sir.
Yeah, it was my privilege. Thank you very much.
Thank you so much for today's session.
Absolutely. Thank you for hearing me out for an hour.